In this problem, once again, what we're going to be looking at is unit conversions. And as well as we're also going to be looking at density and volumes. In this problem, we're also going to be doing some conversion from the metric or from the English system to the metric system. All right. So the problem reads as such. An Olympic-sized swimming pool is 50 meters long by 25 meters wide. How many gallons of water are needed to fill the pool to an average depth of 4.8 feet? So we can find the volume from this. So we know that this is going to be 50 meters by 25 meters by 4.8 feet. And we need to find the volume. Now, it gives us in the problem that the density of the water is 1 gram per cubic 1 gram per milliliter or 1 gram per cubic centimeter. Now, we want to find how many gallons this is going to take. It also gives us that 1 cubic meter is equal to 264 gallons. The first thing we have to do is we have to convert this 4.8 feet, we have to convert that to meters. We have to convert that to meters. And so 1 meter is equal to 3.28 feet. We can do that conversion. Notice that the feet are going to cancel, and we're going to be in units of meters, and this is 1.46 meters. Now, we've done that. Now what we can do is we can actually find the volume of this. We can find the volume of this. And so our volume is going to be equal to 50 meters times 25 meters times the 4.8 feet converted into meters, which is 1.46 meters. We can do this arithmetic, and this comes out to 1,829 cubic meters. So 1,829 cubic meters. Now, what we were given is we were given the density of, I'm sorry, not density. We were given the following conversion, that 1 cubic meter is equal to 264 gallons. We were given that. Now, the problem asks for how many gallons of water. Well, if 1 cubic meter is equal to 264 gallons, then what we can do is we start out with what's given, 1,829 cubic meters, and for every 1 cubic meter, there's 264 gallons. We can multiply this out, and what we get is we get 4.83 times 10 to the 5th gallons. And so in an Olympic-sized swimming pool of this dimension, there's going to be I'm being a little loosey-goosey with the significant figures. There's going to be 483,000 gallons of water in an Olympic-sized swimming pool. Not a shabby amount of water, in all honesty. Now it says, what is going to be the mass of the water in that swimming pool? So what is going to be the mass of all that water? So we can label this part B, our second part of this. Now we know that the density of water is equal to 1 gram per cubic centimeter, which is equal to 1 gram per milliliter. And if you do the conversion and do the conversion, you can find out that this is going to be equal to 1,000 kilograms of water in 1 cubic meter. If you can do the conversion here, so you convert the grams to kilograms, and then the cubic meters to cubic centimeters into cubic meters, similar to what we did in the previous problem. Now we start out with our volume, so we have 1,829 cubic meters. Now the reason I'm using the cubic meters as opposed to the gallons is because I want to find this mass in kilograms. And now we can take our volume, all right, multiply it by our density, our cubic meter is going to cancel, And this becomes a fairly simple problem to solve. So this becomes 1.829 times 10 to the 6th kilograms. So this is going to be equal to 1.8 million kilograms of water. Is going to be the mass of the water in that Olympic-sized swimming pool.